All right, let's try this again. Here we go. Hopefully the audio is working this time. Sorry, guys. So back to 9.2 parabolas part 2. Here we go, guys. We left off in this chart, kind of with this stuff remaining. So remember this. Just recall that for parabolas that are in the form y equals, these things are opening up and down, and then for x equals, these are opening right and left, depending on whether or not the a term out front is positive or negative. Okay, now you guys, there's a ton of algebra and cool algebraic proofs that go into this part that I'm about to go into here at the focus, the directrix, and the length of the latus rectum. If you want to know the algebra behind it and the proof behind it, I encourage you to watch the video on Khan Academy related to this. You could just search on Khan Academy equations of parabolas with focus and directrix, and it'll give you the full proof if you're very interested in that. For most of you, you're probably not, so I'm not going to get into it right here, but I am going to make sure that you guys have the formulas that you need in order to figure this stuff out. So that's here in the chart. Notice that if you have a y equals formula for a parabola, if this thing is opening up and down, okay, so if we have a picture of this thing and say it's opening up and down, the vertex is at a point that we call h comma k. This is just an xy coordinate, right? But it's related to where the vertex is on the parabola. Okay, that same h and k can be used to figure out the focus. Okay, so notice like the focus will always be, and again by definition a parabola is a set of all points that are equidistant from a focus and a directrix. Okay, so the focus will always be on the inside of the parabola. So we can say that the focus may be right there, for instance. And so you notice if something's opening up and down, on this kind of symmetry here, we notice that the x value of the vertex, or the h here, h is what we're talking about when we're talking about the x value of the vertex, that's going to remain the same with the focus. So the focus and the vertex are going to share the same x value, the value that's right here. Okay, but the k value will be different. So to figure out the distance from the vertex to the focus in the y direction, we add 1 over 4a. Okay, that's the big takeaway. And notice if it opens left and right, we add the 1 over 4a to the x value, because we're moving left and right. Okay, so that's the difference between the two. And then the directrix, obviously, the equation switches as well. The x and the h and the k are the x and the y values because it's opening left, right versus up, down. The last thing I want to talk about, and then we'll get into this, is the length of the latus rectum. So the latus rectum, I know it's a funny name, but that value is, or what that's talking about, is the distance from each side of your parabola through the focus to the other side of the parabola. So the latus rectum here is in blue. Okay, it's that distance is what we're talking about. So it helps us determine like how fat or how skinny the parabola is. All right, so that's what this thing does for us, and we will use it here in the next couple of cases. Okay, so keep all that tucked away. Make sure you have your notes for all of this filled out when you're doing these, and refer to them often. So you guys, today for example 3, what we're going to be doing is we're going to be putting equations into the general form, which looks like this. It involves completing the square. So hopefully you remember how to do that, but I'll review it. Then once we have it in this form, typically again using completing the square to arrive at this, then what we're going to do is we're going to use this form to figure out the vertex, the axis of symmetry, the focus, you could use it to find the directrix, but we typically don't need that. The direction of opening, and the length of the latus rectum. Okay, so let's go ahead, and then when we know all that stuff, we can easily graph it without using any XY tables. Now, if you want to use an XY table, there's nothing wrong with that, but you will have to know how to do these things for a couple of the questions on your test. So example 3 shows us this. Okay, make sure you make this fix. This should be a Y on your notes. Okay, this is example 3. Make sure your notes have that fix on it because it's wrong in the textbook. Okay, so here's what I'm trying to get. I'm trying to get my quadratics on one side of this thing and my non-quadratic variable on the other. So notice that the quadratic in this case is going to be dealing with a y squared. So I'm going to just move that y squared term over. Okay, so I have 3x is equal to y squared plus 4y. Now watch what I do here, you guys. I'm going to create a gap. Okay. The reason for that is I'm going to be completing the square to make this thing factor really nicely. But whatever I add in on one side of an equation, I have to add it to the other or subtract it from the same side so that it doesn't change value. Okay, so I'm going to just be subtracting in this case. So a little quick refresher on completing the square. When you complete the square, first of all, the term in front of the y squared term has to be 1, which it is in this case. What we're going to do is we're going to take half of the middle term. So half of 4 is 2, and then we're going to square it. 2 squared is 4. Okay, if I add a 4 in, I have to subtract a 4 as well, so to make sure that that thing stays balanced. Okay, so this then will simplify to this. If you guys remember, it'll always be the square root of the first term with this sign, so plus, and then the square root of the last term. Let me undo that quick. The square root of the last term, 4 is 2, okay, squared. So y plus 2 squared gives me y squared plus 4y plus 4. Okay, but this is the form that I want this thing in, right? Then I'm going to go ahead and simplify the 25 minus 4, which gives me plus 21. The last step is to solve for x, so we're going to divide everything by 3. And notice that if I divide by 3, it's the same as multiplying by 1/3. So to get it in general form, I'm just going to move that division of 3 out front, which is 1/3, y plus 2 squared plus 7. Okay, now that I have this, that really gives me the clues that I need to graph. Okay, the first clue that I want to look at is the vertex. Remember that we have an x equals here, so make sure you're looking at the side of the chart that's an x equals. This is going to open to the right. Okay, it's going to open to the right because it starts with an x equals, and my first term is positive. Okay, so the vertex here, notice this is a y value. The y value is -2. The x value, yes, of the vertex, or the h, is 7. Okay, coming from right here. So my vertex is at 7, -2. Okay, if I don't want to make a bunch of xy coordinates, like plot things in, you know, and plug in numbers to an xy table, I can use a couple of other things that I know about a parabola to figure out where the focus is and where the latus rectum is. The length of the latus rectum, I should say. So we know this opens right, okay? So, and then we also know, if we look at our notes above, that the focus of this thing would be at, the x value is going to be different, okay? So we're going to add 1/4a to the x value, so that's h plus 1/4a. But the y value should remain the same at -2. Okay. Now I know what h is. H is 7. I got that from my vertex, right? So h is 7. So I can solve this thing out and say, okay, if my h value is 7, and my a value is 1/3, which I also know, I can solve this thing to figure out where the focus is. So I'm going to just plug in what I know. Okay, so the h value is 7. So 7 plus 1/4 times 1/3 equals 1/4 thirds is the same thing as 3/4, right? You'd flip it and multiply. So it's 7 plus 3/4, which is 7 3/4. Okay, so my focus is at 7 3/4, -2, which is somewhere right in here. Okay, once I know that, what I can do is I can use my my formula for my latus rectum, which is just 1/a, or the absolute value of a. In this case, my a value is 1/3. So I have 1/1/3, which equals 3. So the length of the latus rectum is 3, which means I'm going to go 1.5 in this direction, 1.5 in this direction. So we have something that looks like this. Once you have those points, you're just going to connect them, and you're good to go. That's all I need from you guys. So that's example 3A. 3B is a little bit easier because they have it solved for y. But let's go ahead and do this one. So we're going to complete the square. We have x squared plus 6x plus blank minus 4 minus blank. Okay, again, completing the square, half of 6 is 3, 3 squared is 9. If I add a 9 in, I have to subtract a 9 so that I don't change my value. Okay, so now I am left with this, y equals this factors to x plus 3 squared minus 13, just combining those guys. Okay, so in this case, my a value, there's nothing out front, so a is equal to 1. The vertex of this thing is -3, -13. Notice the x value here is first, which means this thing is opening up. Okay, so at -3, -13, I can put a point, and I know this is opening up. The latus rectum, the length of that thing is just going to be 1 over 1, which is equal to 1. So in either direction from my focus, I'll go out from 1. But first I need to figure out what my focus is. Okay, so for the focus, notice that my x value of the focus, if this is opening up, has to stay the same. So that's how I kind of keep this straight. The focus will be h, comma, k plus 1 over 4a. Okay, remember that this is h, this is k. So the focus will be at -3, comma, -13 plus 1 over 4 times 1, because my a value is 1. Okay, so that's -3 and then -13 plus 1/4, which is -12 3/4. Okay, so at that point, I'm going to put my focus, -12 3/4 is someplace in here. And then through that, the latus rectum is 1. So I am going to go a half in either direction. Okay, so we'll go halfway here. This is just 1, so it's just halfway in between, halfway in between. So we know that this thing is pretty skinny. Now, I might want to get one other point on this just to make this a little more clear since this is small. So a good value to plug into these things is always 0, right? So if I plug a 0 in for x, 0 squared plus 6 times 0 minus 4, these go away. At 0, I'm at -4. Okay, on the other side, I should be the exact same distance from the symmetry line. So I'm going to go over to here. And now I have a nice complete graph. All right, so that's example 3. Okay, so I'll be looking for these things, the latus rectum, the focus, the vertex on your work. So practice those. For example 4, you'll have to do that in order to get these. They want to come up with an equation of the parabola given a focus and a vertex or a focus and a directrix. Okay, so what I do on these, you guys, is I just draw a quick sketch just so I get a rough idea of what's happening. So the vertex is at 1, 3. The focus is at 1, 5, right? So I know this is opening up. That's important. If it's opening up, this is going to be a y equals, and then we're going to have some x value in here. Sorry, I should say here, squared, and then yeah, so we can figure this out. So notice, if this is a 1, this factor has to be whatever would make this go to 0 if we plug a 1 in, so it would be -1. And then the y value is always out here, okay, when it's a y equals. So we have this guy. The thing that we're missing is the a value. So to find the a value, I can use my equation for my focus. Okay, so the focus in this case, the x value is going to remain the same. Okay, so my focus for one of these, the x value will remain h, which is 1. But then it'll be, for the second part, it'll be k plus 1 over 4a. And the a is what I'm trying to find. Okay, so this whole thing has to be equal to 5. So I'm just going to set it to equal 5. I happen to know k, okay, because this is h, this is k. So I'm going to replace this k with a 3. All right, and then to solve for a, I'm going to subtract 3 from both sides. So I get 1 over 4a is equal to 2. I can multiply both sides by, or divide both sides by a fourth, I should say, to get a by itself. And if you do that, or if you need to see that out, what you can do is this. You can multiply both sides by 4a, right? So you get this. And then divide both sides by 8 to get a by itself. So you get 1/8. All right, so that is 1/8. And we are done. We have our a, we have our thing that makes the x value go to 0, and then we have the y value there for the vertex. And that's all we need. That's the general form. So for b, this thing, again, I want to sketch it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So at 5, 6, we have a point. And that point is the focus. The directrix is at x equals -2, which is back here. Okay, so a quick hint for you guys, the vertex will always be exactly halfway between focus and directrix. So we know that just by counting that this distance between the directrix and the focus is 7. So halfway between, half of 7 is 3.5. So I'm going to count up 3.5 from -2. So that would be -1, 0, 1.5. Okay, so at 1.5 I have my vertex. Okay, and that's in the x direction. My y direction will not change. All right, so 1.5 is my x value for my vertex, and my y value for my vertex is the same. So that would be 6 in this case. Okay, so we know this opens to the right, therefore this is going to be an x equals. We do not know a yet, but we can find that pretty soon. We do know that the x value, so notice guys, if this is an x equals, this will always be y here, right? So the y value, what makes y go to 0 is this, and then we add our x. Okay, so to find a, I can do what I did last time. I know that for the focus on this particular one, the focus is going to be, so just to keep this all clear, since our focus is here and this thing is opening to the right, I know that the equation for the focus is going to be the one that's up here. I'll just refer to the chart. Okay, so the focus, when you have an x equals, is this guy. H plus 1 over 4a, comma k. Okay, so h plus 1 over 4a, comma k. I know h, I know k, so I can solve this thing for a. Okay, so k is equal to 6, so I already know that. H is equal to 1.5. Okay, so how I do this is I would take the 1.5 for h, plug it in. Okay, and I know that this has to be equal to 5. All right, so what I did was I took h, plugged it in here, and then I know that my focus, the x value of my focus is 5. That's where I'm getting my 5. So I'm going to subtract 1.5 from each side. Okay, multiply both sides by 4a, and I believe you get 14a is equal to 1. Therefore, a is equal to 1 over 14. Plug it in and you are done. All right, guys, this is going to take some practice for sure. Refer to your formulas often. I'm happy to work some of these with you guys if you have any issues. The homework sheets, I think, are posted, and those are due, I believe I have them due by the next class period, so you guys have plenty of time to work on this. Have a good rest of your week and weekend, and we'll see you guys next time.